Hello and welcome everyone to Get Electrical Engineering Previous Year Question Solutions. This is about me. I am Jitendra Kumar, and today we are going to see one problem based on single phase induction motor. So, what is single phase induction motor? There are certain similarities between three phase induction motor and single phase induction motor, but there are some differences as well. Single phase induction motor not self starting. This is the first drawback of single phase induction motor. Secondly, its running characteristics is poor. Running and starting characteristics is poor. But we knew from three-phase induction motor that to rotate any induction motor, we we need three-phase winding. In three-phase winding, phase difference in time, phase difference in time and a space both should be 120 degree. A space and time. Then it will create a rotating magnetic field due to which our rotor will rotate and torque will be produced. So this was the basic philosophy of three-phase induction motor. But what about single-phase induction motor? Generally in two-phase machine, both two-phase, both the phases are displaced in a space and time with respect to 90 degree of each other. Then it can also create a revolving field. So that is the purpose. We want to break a single phase winding into two components where there will be certain displacement in phase as well as time. So let us move ahead. Here in induction motor, this is the forward EMF and this is the backward EMF. Now there is only one phase of winding, so the winding can be written as Fm cos theta cos omega t. Okay, so this is the time, this is the space angle, right? Now, can we break it into certain two-phase type of thing? Certainly we can. We will break it. We know the basic trigonometry identities from 10th class that cos theta minus omega t plus cos theta plus omega t. So this is some way you can recall this is forward, this is backward. So here it is forward MMF revolving field, and here it is backward MMF revolving field, right? So to denote this MMF or due to this MMF, there will be some back EMF, or we can distribute winding into two parts. One is forward and one is backward. So that's why it is distributed here. However, there is nothing we have to do with this in this problem. To solve this problem, we just need to calculate power factor. So let us go to that. And for more details, we will discuss in live sessions, which is scheduled every Thursday, 6 to 7 p.m. So this week we are going to discuss this in detail, single phase induction motor. For time being, we will move to the solution. Right. So for power factor, we need resistance and inductance. Power factor is tan inverse. Power factor angle is tan inverse X equivalent divided by R equivalent. Right. Now, The question is saying that at no load, the motor speed can be approximated to the synchronous speed. Means NR is equal to NS. What will happen if NR is equal to NS? Since slip is equal to Ns minus Nr divided by Ns in conventional induction motor, right? But here we are creating two kind of field or two kind of slip. So here one slip would be forward slip and one slip would be backward slip. And the relationship between this is the forward slip and Ns plus Nr by Ns is backward slip, and we can write backward slip as a 2 minus forward slip. And this SF is generally written as slip. So this slip is nothing but this SF, right? Huh. So at NR is equal to NS, SF would be 0. Means S would be 0. What will happen if S would be 0? Let me change the pen color here. So if S would be 0, this this is going to be open. So this is not going to work, right? This will be treated as open circuit. Here S is 0. Now it will become R2 dash by 4. So let me draw the equivalent circuit in the next slide. Here Xm dash by 2. Here also Xm dash by 2. And R2 dash by R1, XL1, Xm2 dash, Xm2, Xm dash by 2, R2 dash by 4. And here also XL2 dash. Now this is just a network theory problem. We have to find power factor. So R1, first we will calculate equivalent impedance, and after that we can find what will be the angle of impedance, and that would be the angle of power factor of the circuit, and that would be the answer. So we will calculate here R1 plus JXL1 plus JXM dash by 2 plus R2 dash by 4 plus JXL2 dash is in parallel with JXM dash by 2. So R1 is given in the problem. R1, R2 dash, XL1 and XL2 dash all are given and all are 12 ohm. But magnetizing inductance or magnetizing reactance is 240 ohm. So that is high. So since most of the parameters are same, so it would not be any problem. So R1 is 12 plus XL1 is also 12 plus XM dash is 240, so half is 120 ohm plus this we have to solve in parallel. So R2 dash by 4 is 3 plus J XL2 dash XL dash by 2 here. Sorry for that. And it would be 6 in parallel with J XM dash by 2 is 120. So further, if we will solve, this would be 12 plus J 132 and plus uh, K360 minus 720 divided by 3 plus K126. So if you solve it further if you will solve it, you will get the answer. Sorry, you will get the answer that would be 14.719 plus 137.779 J. And we just need power factor. So we will not waste time in calculating magnitude if this type of question will be asked in GATE exam. So power factor is cos of tan inverse 137.779 divided by 14.719, and it would be cos 83.9 degree, which will come 0.106 lakh. So there was one option in this problem. No, I think it was numerical answer type. So here we had to put 0.106. So that would be the answer to this problem. For more detail, please attend the live session. Thank you.